Good morning. In this lecture of LTE, we will discuss LTE network architecture. So, topics will be covered today are LTE architecture, LTE radio interface, and LTE core network. So, LTE, that means long-term evolution, or 4G networks. The main aim of this is high mobility. So for high mobility, you want to reduce the complexity of the network. So this becomes our main aim, that means to reduce complexity of network. This complexity can be reduced by reducing the number of nodes. So we need to focus on number of nodes in the network. So what are the number of nodes? Like I will compare with both technologies like 2G. In 2G, there is mobile station. This mobile station is attached with the help of air interface with BTS, BTS with BSC, BSC with SGSN. We are concerning here data, so I will write only data entities here because for voice we have a separate controller as MSC. So SGSN is connected to GGSN and this gateway is connected to the external public data network. So if we want target access, then we have to contact PDN and we will have packets from PDN to GGSN, GGSN to SGSN, BSC, BTS and mobile station. So these are a number of nodes between mobile station and PDN public data network. That means we have 4 nodes in between user end and external data network. So in 3G also, user equipment. This UE is attached again with the help of air interface with node B. Node B with radio network controller, that means RNC. RNC is again with 3G SGSN. This SGSN with GGSN and PDN. Now that we have increased the hardware efficiency as well as software efficiency, but the number of nodes between user equipment and the external network again the same, or 4. So in order to reduce the complexity of the network, that means to reduce the number of nodes from the network, they focus on reducing the number of nodes by eliminating RNC. So this is my 4G. 4G's UE is directly attached to E node B, evolve node B, and evolve node B is attached to the core network, and this core network is attached to external PDN network. That means if you want high mobility, so you require lesser number of nodes for packet access, so we have reduced the number of nodes. So in this, that means in 2G architecture, whenever we have evolved the GPRS network or GSM network, for 3G, we have changed this part. This is radio part. That means for 3G evolution, we have focused on the radio access network, or we have changed the radio access network with new equipment as Node B and RNC. But the core network remains the same as that of GPRSH, I can say 2G services. So, in order to have 4G, they want to add on something new and they want to have some new architecture. They don't want to use the previous architecture that we are using in 2G and 3G services. They want to use the new architecture, new components with high efficiency. Then only you can expect high data rate. So what are the components in there? Every architecture has basic entities. Like first, they want mobile station or they want used equipment. The very first requirement of any network architecture. Next is the UE should be attached to a RAN part. RAN is radio access network. That means UE is in direct contact with radio access network only. And this radio access network is controlled by CN. CN is core network, and this core network should be attached to any external network for databases access, like for internet access. So these are the basic requirements for any network architecture. And besides this, you want an operation and maintenance center also. So these are the requirements, any basic requirements of any network architecture. For 2G, the RAN part is BSS and the core part is NSS. From 3G onwards, we named that RAN, radio access network, and this is our core network. So in radio access network, if this is radio access network of 2G and this is radio access network of 3G, in radio access network of 2G, we have BTS and BSC. And in RAN part of 3G, we have Node B and RNC. This is base station controller and this is radio network controller. That means who is controlling these BTS, number of BTS or number of Node Bs? BSC and RNC simultaneously. So that means that radio access network has been controlled by a separate controller and user has been controlled by a different controller. For direct access with user, you require BTS, but all BTS are controlled by BSC. The same thing is there in 3G. The user equipments are controlled by Node B, but all Node Bs are controlled by RNC. That means in one radio access network, you are providing two separate controllers. Now, we want to remove this separate controller here, over here. That means in 4G radio access network or RAN part, if this is 4G, we don't want a separate controller. That means a single controller is enough. Yeah. Why a single controller is required in 4G? Because high mobility again is the main concern. High mobility, that means there should be faster handovers. If your aim is providing internet connectivity in fastest mobility, that means your handover should be faster and faster. That means for high mobility data connectivity, handover should be faster. Now, in case of 2G, whenever mobile station, or in case of 3G also, whenever mobile station or user equipment wants a handover, it will send RX level and RX quality. That means your MRs, measurement reports. Because in measurement reports, we have RX level and RX quality. So the mobile station continuously send MR to BTS and BTS send these MRs to BSC because BSC is the controller for all BTS. Now BSC here will take or handover decision. That means handover decision is with BSC and simultaneously in 3G RNC. So handover process is long, it will take long time, or we can say the latency is more. So in 4G for faster handover, all handover decision is with E node B because we don't have a separate controller over here for handover decisions. That is the reason we have removed the RNC or BSC from the 4G networks, and all the decision making capability or all the decision making is with E-Node B only. So E-Node B is only the separate controller in the radio access network who is there to taking decision of the handovers or power measurements. Now, network architecture. So here I have user equipment, UE. UE is, now this UE is LTE user equipment. That means it must support MIMO configurations, multiple input and multiple output, because 4G handsets work on MIMO configuration for faster internet reception as well as transmission. Now this UE equipment, with the help of ear or UU interface, this is always wireless connectivity, so this interface should be radio, it should be ear, and it is named as UU interface. Okay, with the help of UU interface, we are attached to a part, that means to a radio access network, and in this it is named as E-UTRAN. Because UTRAN is there for 3G services, Universal Terrestrial Radio Access Network, and here we have used E. Why E? E for Evolved Universal Terrestrial Radio Access Network. E-UTRAN we named for 3G. Now 4G has everything new, so evolved E-UTRAN. Now in evolved E-UTRAN or E-UTRAN part, we have only one controller, and that is E-Node B. So E-Node B is evolved Node B, because Node B we name for 3G. Here we have evolved Node B because this is new one as compared to 3G services. So evolved Node B 4GBTS. So this is the radio access network with only one separate controller, that means E-Node B. Now this should be attached to a core network. Now, talking about core networks, that means I can also write here NSS part. Okay, so in core network for GSM, we have MSC and databases. That means 2G. So when we require data access in case of GPRS, so we added on here SGSN and GGSN and external and all its databases. So this is the previous core network, but we have added on a new entities in this. Now for 3G, we have changed the radio access network, but we have not changed the core network. Now we want, that means this core network till 3G is the same as that of 2G, 2.5, 2.75. But now we want new core network here in 4G systems, and that new core network is EPC. That means this is my evolved packet core. Now again evolved, because 4G is a evolved new technology, new architecture and new components, so evolved packet core. And this evolution of whole architecture, this whole architecture evolution is is SAE. That means System Architecture Evolution. System Architecture Evolution. Evolution of a new system architecture. That's why SAE. So I will draw here full architecture. E and B for evolve node B. Now this is EPC or Evolved Packet Core. Now here are the databases in Evolved Packet Core network. Now I will draw here bold lines and dotted line. Bold lines and dotted lines. So this is Evolved Packet Core. So in this Evolved Packet Core, we have a number of databases, but all databases are IPly connected. Because 4G has an aim of IP connectivity, but not fully IP connectivity. And full IP architecture is the aim of 5G networks. So IP connection, so MME is mobility management equipment. MME is mobility management equipment. HSS is home station subsystem. SGW is serving gateway. PGW is paging gateway. PDN is public data network, and PCRF is policy control radio function. So these are the number of entities attached in the EPC or Evolved Packet Core. Now this interface is UU interface or air interface. Now talking about the connectivity between two E-node Vs. Okay, we require connectivity between two E-node V. Why? Because for handovers, now there is no separate controller. So all E-node Vs are connected to one another. So the interface between two E-node Vs is X2 interface. The E-node Vs between or connectivity between two E-node Vs are X2 interface. Now, bold line will represent data flow and dotted line is there for signaling flow. The full interface between E-UTRAN and Evolved Packet Core is S1 interface. This interface between this E-UTRAN and EPC is S1 interface. For now this for signaling S1C, where C stands for control plane, and for data we have S1U, where U stands for user plane. User plane will represent data, whereas control plane will represent signaling. So every E-node B for signaling purpose has to contact MME and HSS, and every E-node B for data has to contact serving gateway, and paging gateway through to PDN. Now, what are the functionalities of this? MME, Mobility Management Equipment. Like functions are same, but we have organized the function in different databases so that processing will be fast. Now, mobility management equipment, as the term here mobility, that means it has to deal with changing locations. Then all changing location, that means faster handover, changing locations is there for mobility management equipment plus authentication processes is there in mobility management equipment. For example, eNode B, a mobile station want a handover or user equipment wants a handover. So user equipment needs to contact to eNode B. Now eNode B will give a handover, but after handover, eNode B needs to inform MME that I have given a handover, please update the location. So for location updation and for changing location, we have a controller mobility management equipment. Now, home station subsystem function is same as that of HLR. That means it is a permanent database of subscriber related information. That means all subscriber related information is there in HSS. That's why both these databases are used for signaling purpose. Now, these databases, that means for user plane databases, we have serving gateway. Now, serving gateway has a functionality of like same as that of SGSN. That means all data packet routing to transfer, saving the IP address and connectivity with the PDN. That means the external network of any database. This is, we are connected with the help of serving gateway. That means all routing of data packets is there with serving gateway. Now this paging gateway serves same as GGSN, but it allocates IP addresses, different IP addresses, and it is a gateway to the external databases. Like Facebook is one database, Gmail. So we have number of external database. The connectivity of one serving gateway is with the help of number of paging gateways. And plus IP allocation is there for paging gateway. Now PCRF, that means policy control radio function, is there for connectivity for 3GPP and non-3GPP services. That means for handover from one generation to another generation. For example, if we don't have 4G connectivity, then for handover to different generation or third generation is with policy control radio function, and all protocols work on this. So this is the complete LTE architecture, and this evolution of new architecture is system architecture evolution. This new core network is evolved packet core, and this is evolved UT-RAN part. And these are the X2 interface and S1 interface, S1U and S1C interfaces. So in this class we have covered about LTE architecture, interface, radio interface, and core network. So after that we will discuss what are the functionality of each and every databases and what are the internal interfaces. So this is enough for today. Rest we will continue in next class. Thank you so much.